Axial versus shear strain.
For axial strain, we have a rod like this. Length if we pull on it, it gets longer. Delta strain is delta L over L. Notice that the deflection is the same direction as the force, and it's lengthening in the same direction as the force. Shear strain is quite similar, but slightly different. If we pull on it perpendicular to its length, it deflects, delta Y. Notice the deflection is perpendicular to the distance that's moving. The force and deflection are in the same direction, but the dimension that affects that change of deflection is perpendicular. This is a shear strain, and the shear strain is given by delta Y over L. Notice delta Y is perpendicular to the distance L, original length. So normal strain, same direction, shear strain, perpendicular direction to perpendicular direction. Now notice this little angle gamma. Gamma is delta Y over L. It's actually the tangent of delta Y over L. Now notice if your angle is very small, then that tangent of delta Y over L is approximately equal to delta Y over L. That's our small angle approximation we've been using since calculus. So we find that the angle of this shear deflection, gamma, happens to be equal to delta Y over L, which is equal to the shear strain delta Y over L, so that gamma happens to be delta Y over L. So the shear strain is delta Y over L, and it happens to be roughly that angle. And so we call that the shear strain, that angle, which is just delta Y over L. This, for normal stresses, the deflection is in the same direction as the dimension that's lengthening, and the force is in the same. The force and the change in dimension and the original length are all in the same direction. Shear strain, the force is perpendicular to the dimension that's getting deflected. That deflection is perpendicular to that length that's affected, but the deflection is in the same direction as the force. So the deflection is also in the same direction as the force like before, but the length is perpendicular, and it results in a shear strain that happens to be the same as that angle of deflection.
That's how we do shear strain for direct shear.